And we're off and running. So last week, we really jumped off into the deep end. We started learning JavaScript, right? It was a big change of pace from what we were doing with HTML and CSS. Now we're learning to program with a language that lets us control logic and functionality. So we learned the basics of the language, right? Last week we were learning about arrays, and we were learning about objects, variables, all the things that you need to know to be able to write JavaScript. But in terms of web development, the thing that we really need to dive into and start exploring now is how do we interact with the actual page, the page itself. We played with a few of those things last week, and we just briefly used like document.getElementById, right? That's a DOM method. We played with the .innerHTML, but we didn't really dive into or explain what that parameter is or how it's used. So really today and going forward, we're going to focus exclusively on the DOM this week so that we can start building programs that interact with the web page. That was a cute little, we were talking about Git last class, so I added this image. It's a funny little joke. All right, cool. So we've learned about, we spent some time, we've been playing with this over the last week or two as we've been exploring development together, but we wanted to spend a little bit of time today and focus on like how do we formally debug things. And we've experimented with this a little bit last week when we were talking through how do we find the current values of our variables. The go-to answer here is to start from the developer tools, always to use console.log whenever needed, right? So that we can write information to our page, right? So like hi. Right. So as we're writing code, using console.log should be your first reaction, right? This should be the first thing you pull out of your tool belt to explore the current value of the variables. Some of the other things that we looked at, there's another example. Let's pull open a code. I'm going to make just a simple little project here for ourselves to start playing with JS. Make an index.html. And we're going to make a little project for ourselves. I'll make this bigger for y'all, right? DOM and debug. And so I'm going to simply put in a script tag that we can explore some of these debugging methods with. Source equals JS, and I'm going to call it app.js, right? Nothing fancy. And I'm going to give myself h1 debugging and playing with the DOM. Okay. So if I make app.js in here, app.js, let's make sure we defer this. Defer. And if we come in here and we for example, I make a loop, right? We learned about loops last week, so I say for var I equals 0, I is less than 10, I plus plus, right? Console.log I, right? So as expected, this should just log 0 through 10 to our, or 0 through 9 to our console, right? And if we pull open our console, we should see that here, right? 0 through 9, perfect. But what if, right? What if we wanted to automatically go into the debugger, right? And see what the thing was at every step of the way. We've learned last week that if you click on the sources tab and we open up our script, right? I can put a breakpoint in here, right, by clicking on the line number, so that when I load this page, it's going to stop the execution and then let us cycle through each and every, all right, if I press F10 here, right, F10, or one of these, right, F9 is a step, right, it's going to show us that I is 0, and if we watch, so we can watch our I here, and you can see that go up each and every iteration. But what if we didn't want to have to manually go into our debugger like that? We didn't want to manually, how do I turn this off? Right, zing, wrapper. If I wanted to, we have this cool capability where I can write the word debugger, right? If I can write the word debugger, and it's just a statement like this, and that code is going to automatically stop the execution when it gets to that line and put us in debugging mode, right? The exact same thing we were doing before with the breakpoints. And so now I could continue to press F9 or click this button and watch this I variable increase as we go through the lines of code. Okay, so the debugger command if you're inside, generally you're going to be working in JavaScript files that are very large, right? But you know you want to debug something. Maybe you don't want to have, you don't want to go through a big list of files and stuff in here. Just to give you like an example, if we clicked on the sources tab here, right? Like this is all the stuff that Google is including in this app, right? But if you're working inside of a file, just being able to come in here and write the word debugger will automatically halt the execution and put you into debugging mode so that you can step through your code. That is the debugger statement. Okay. Any questions about that? The one thing to note, right? This is going to do it as soon as this code is executed, right? So if you include this debugger line in your code, right, and you publish it to a server, this will stop execution for every visitor to your page. So you want to make sure that if you're actually publishing your code on the internet, you take out these debugger statements. Make sure that there's never any in your code that's being submitted. Okay? Close this down. Yeah, perfect. We talked about breakpoints. You can set a breakpoint at any time by clicking on the line number that you want to have be the breakpoint. It's going to show this here. It's going to say, I'm going to stop at this line, I'm going to stop at that line. Okay? Any questions? How can we simulate the call stack? Let's write a few functions real quick. I'm going to say function call the loop. Okay? Console.log call the loop. And then I'm going to say run the loop. Okay. I'm going to make another function called function run the loop. And then we'll put our loop in here, right? And then what I'll do to kick this off, I'm going to say call the loop and execute my function by putting parentheses here, right? So if I take out these breakpoints, reload our page, right? The code is there. We can see that it's still console.logging. If I wanted to, right, if I put in, let's just put in a debugger statement here. Debugger. Okay. We're going to start the debugger at the top, and then we're going to kind of walk through this together because I want you guys to see kind of the call stack here, right? So call the loop, right? So debugger runs, and the very next line of code that runs is call the loop, because these are like declarations, right? When we declare a function like this, it creates the function, but there's nothing to execute, right? These are not executed until we call it. So you can see that our call stack is we're on line 17 of anonymous, and anonymous just means we're inside of like a global scope. If I click next, now you can see things have gotten interesting, right? We've called call the loop. It's telling us, we are now inside, right? So line 17 called this function. So now we're on line 6 of call the loop. This is our call stack. And so if I was to click in here, right? Now we're going to call run the loop, and you can see the call stack is showing, hey, we started at anonymous, then we called call the loop, then we called run the loop. Okay? This is the same sort of code. If I if I was to call in here console.warn before we even run this loop, console.error, right? See call stack, right? The call stack is the order of functions in which they're called from start to finish. And so if we load this page now, right? Let's actually, right? Let's run through. Right? See call stack. The call stack is showing you from top to bottom. This was the initial lines of code. Right? It's called anonymous because it's not inside of a function. Then it called call the loop. Then it called run the loop. And line 12 is where we had that error. So when we're looking through the debugger, we can watch that call stack being generated. Right? So it's going to call the loop, line 6. Then it's calling run the loop, which tells us, like this arrow is telling us where we currently are in the call stack. There's a type of looping that we didn't talk about really yesterday because it's more advanced, where it's called recursive functions, right? So we can say, we'll save that for a different day. But we can essentially have a function call itself over and over and over again until some condition is met. And maybe we'll see that when we play with some of our DOM functions this week. But this call stack is useful to let you know how you got to where you are from start to finish. It also shows you the scope, right? So this, in this context, refers to the window object. When we start learning about object-oriented programming, this object is going to be referring to a class or an instance of a class, and it won't be tied to window, right? So right now, if I was to write this dot, title or something, right? It's talking about the window object, okay? As we start to run more asynchronous functions this week, and we start playing with event handling code, right? This object is going to be referring to some HTML element, right? One of our nodes. This debugger is extremely powerful if you're ever overwhelmed, if you're ever trying to figure out how we're getting to where we're going. Like, last week there was a bunch of questions around loops and loops inside of loops. We could have gone through this debugger step by step and watch each of these variables to see what is actually happening behind the scenes. Right? We can add I, right? So I is being watched, and you can watch these numbers iterate. This is a good way if you're ever struggling with visualizing what is happening. This debugger is extremely useful, and you can always turn it on by just running debugger or going to the sources tab and manually adding a breakpoint. Any questions? Any questions about any of the debugging stuff? We're going to continue to look at ways as we build projects together, as you watch me try to struggle and code in front of you live, like the right technique to use to figure out what's going wrong is going to be dependent on how complicated your code is. Like, if I just wrote 3 lines of code and then my program breaks, I guarantee you that my 3 lines of code I just wrote are the problem. If I write 50 lines of code or 200 lines of code, or something goes, we write some code that is working, but then I type in a word in the form that causes the code to not work correctly, I might have to pull out some beefier tools like this debugger to figure out how we got to where we are. So looking for opportunities to get better at debugging and better at troubleshooting errors is essential to being a good software engineer. Any questions about debugging? Oh, go ahead, Kreef.
So is the debug, do you add the debugger while you're writing code, or is that added once you find a mistake so that you can find, is it like added periodically?
So
or
you would,
you put it in and it'll search
if you put it in your code, it will stop execution of your page and move you into the debugger. I would only ever use that debugger code, the debugger statement, right, if I needed to troubleshoot something. Otherwise, and you see me do this all the time, and I encourage you to do the same thing. I'm gonna call console.log pretty frequently because I don't want to go into the full debugger. I just want to see, like, show me on the console what is going on. And so I would say, like, what variable is this? This, right? And I would paste the variable in here, right? So I can watch what's happening without needing to go into the debugger, because the problem with the debugger, to me, is the debugger stops execution. Like, every time I reload the page, nothing else will continue to run until I continue to step through the lines of code. Right? This is kind of annoying. I want to just see my code work without having it stop.
So the console.log would just follow through the code but won't stop it.
Correct. And it will print it to the console. The debugger is really like for when you've got a bug that is so insidious that you can't figure out why it's happening. It will let you step through line by line to see, like, okay, the value of this is currently that. So if you had a whole bunch of conditionals, right? You said if the value of first name equals Karif, do something special. And then you write in Karif and you think this should work, right? Stepping through it will let you see, oh, okay, I put Karif space, or something that is causing things not to show up correctly.
Okay, and that's console.log and not debugger.
You can do it in both places. It just entirely depends on how you want to debug.
Okay.
Just think of it as a tool in your toolbox of, like, if I need to pull out the big guns, I can use the debugger, whether by writing the debugger statement, right, like this, or you can always just come in here and say, like, this line of code is broken. Why is that breaking? And if I reload this page now with that breakpoint set, it stops at that line.
Okay, follow.
Yep. Oh, I should turn that off soon. Reload. Stop. Reload. Good. All right. So what is the DOM? We've been talking about it. We've mentioned that the DOM stands for Document Object Model. It's a fancy way, right? When JavaScript first became a language, they needed a way to take the HTML content of the page and turn it into an object that can be used for JavaScript, right? So that JavaScript can work on elements, see the value of things, change elements, move colors around, do all that sort of thing. So every time your page loads, if JavaScript is turned on, JavaScript turns the page, the document, into the document object model. It is created by JavaScript for the purpose of letting JavaScript operate on the page. It is a hierarchy starting from the very top. The very top is document, and it goes on down into the structure of the page. It lets the JavaScript read, write, and interact with all of our HTML elements when we build websites and pages. It is an object-oriented representation. Object-oriented, we're going to learn about that. It means take some concept and turn it into an object that we can reference and replicate, right? I'll show off this this type of. Let's see if I can make this bigger. Let's present maybe. All right, perfect. Hopefully you guys can see this. So at the top, right, we learned that the document object model starts with the window object, right? The window object is our global object that everything in JavaScript starts from. Then it loads the document. This is the actual HTML of your page, right? And so there's a whole bunch of objects and attributes on the document object that exist within the window object that we can use to change information about the page. And then there's a whole bunch of other stuff. This is really just like a loose representation of kind of the structure of how this works, right? The document object has, you can get all the links on the page with document.anchor, right? Let's show this off maybe. Do we have maybe one of our projects from? Let's see if we can find a project. Maybe this one that has a lot of HTML in it. Yeah, cool. Do we have a menu in here? Yeah, this one will be fine. I'm going to open this up with our server so we can play with the document object. So we have this page, it's got some images, it's got some forms and some tables. So if I open this element up, I open up our developer tools, right? We can see the document object, right? It refers to the entirety of the page, but there's a whole bunch of other properties under here, right? So one is document.links, which is going to contain all of the hyperlinks on the page, right? And if we scroll over them, right, you can see these are the two that are at the bottom, and I think there's one at the very top, right? So document.links has all of the elements that are links on the page available to us as a part of the document object, right? You'll also notice that this is showing that it's an HTML collection. Now, these aren't truly arrays, though they do operate kind of like arrays, right? So you'll notice this is a collection that has 3 elements in it, right? Document.links, right? It has all of the same sorts of things that you would expect a link to or an array to have, right? We can do .length. It's going to tell us there's 3, right? We can loop over them. We can reference them individually if we need to, right? We can say, hey, give me document.links, the second element, right, in the 1 spot, which is going to be this one down here. So all of these HTML elements that we're going to operate on in the document object model are array-like, right? They're intentionally designed to be array-like so we can loop through them, so we can iterate through them, but sometimes they don't have some of the array methods that we expect to have on the traditional array object. So, for example, .forEach, right? That is an array function, but it does not exist in document.links, right? Because that is an HTML collection, not an array. So be aware that even though it feels like an array, there are things that are missing from a traditional array. Where if we said, new array 1, 2, 3, right? For each function is here. So some of the array methods that we, if you were going to W3 schools and looking at all the things you can do with arrays, some of those will not exist on DOM collections and some of the DOM specific functions we're looking at. So that's document.links. There is also document.anchors, right? So this is empty, even though you'd think, right, like an anchor tag is, like these are anchor tags, right? But we call document.anchors, and it shows up there's nothing in there. And the reason for that is document.anchors is for internal links. Let's see if we can figure out how to use this in a way that's quick. Let's see. I'm going to search document.anchors, and they probably have a good example. Yep. So any anchor tag that has a name attribute, right? So that's for the internal linking. Do you guys remember that from week 1 when we were linking internally to the document? Would show up in document.anchors, right? So if there's any internal documents on the page, let's see. What's a good one, right? Wikipedia always has lots of anchors on their pages. Wikipedia. Just pick some random article. I don't know who this person is, but more tools, right? So document.links is going to be all of the links external on the page, and document.anchors, oh, they don't have any in here either. That's annoying. Do they not have any internal links? Thought all these little, it should be, I don't know. So either way, there are better ways to do this. So that's one of the ways that you can interact with elements on the page for anchors, right? There's also, if you have a form, you could run document.form. Do we have any forms in here? Yeah, let's go to forms.html. Forms.html. All right, so document.forms is going to be a reference to any forms that are in your page, right? It's going to show up as an HTML collection, right? So if you have multiple forms, there will be multiple elements in this list. So you can see that the 0th form and all of the inputs that are associated with that form are also included, right? So if we were to say document.forms0, right, is a link to that form element itself. So that's kind of the old school way of doing things. The way we've been interacting with our pages, with our elements, is generally by one of two methods, right? Document.getElement by ID, right? That's the main one, where we're saying, hey, give me a reference to a specific element. Or give me a reference to a specific set of elements that match a selector, right? The other one was query selector all, which gives us, we could put in actual CSS selectors in here. So we could say, do we have any CSS selectors in here? New page source. Let's see, what do we got? Oh, well, we can just use input, right? So instead of calling a class, we can say input, and that's going to give us every input on the page. Generally, the old way of interacting with forms with JavaScript and with the document object model in like the early days of the internet, right? We would actually literally go in and say document.forms, right? And then we would, go to 0. We would iterate through these elements in that specific method. Nowadays, most modern web development says you're going to define really good elements in your HTML so that you can write very good, clean code that is either referencing elements by an ID or by a query selector or by a class name. So almost always, we don't use this type of document manipulation where you're literally iterating down through the document object, right? Because there's a whole bunch of stuff in here. Document.all is a great example where this is the entirety of the HTML page in an HTML collection, right? All 108 elements of this page are here. This is a deprecated feature. Even though it still exists, at some point in the future, it might disappear. So you never want to rely on this type of DOM navigation anymore. Any questions? We're gonna continue using lots of examples of this. We're just high level right now. Other good examples, right? So with the document mod, right? So document.all is the entirety of the page. Document.head is the link to the head, right? That's where we put our title and our things like that, right? Document.title is the title of the page, right? That goes in here, right? We can change this by saying document.title equals something else, right? And keep your eye on this up here, right? It changed the title of our page, real time. So if you're building a cool app, right? If you're building something that maybe it's like a Gmail client or an email thing, right? What some companies will do, when you're building this kind of code, is you'll come in here and change the title, and it would say, they'll put in a number 1, right? Else, right? So that as you get unread messages, they'll just come in here and keep updating this value, right? Now there's 2 things unread. Now there's 3 things unread, right? So this is kind of the standard way, right? So document.title is a reference in the document object model to whatever the value is in that title attribute or that title element inside of our head. We could have also gotten there through document.head, right? Which is a collection that has a title. We can also, because this is a reference to the element, document.head.inner.html is the actual HTML of the image, or of that header, right? Same with document.title, right? We can do dot outer HTML. That one doesn't have a title as a special attribute. Then there's also document.body, which is the body of the page, right? We can do document.body.inner.html. That's all of our HTML that we have here. Right? It's the same as if we'd viewed source. Right? And we get some of our code that's injected from the server. View page source. Wait, what? Oh, I'm in the wrong server. Oh, yeah, that's why. We've talked about, I talked about so that's how you could reference the DOM kind of in the old-fashioned way. You can go through document.all, you can go through document.head, document.body, but generally, you're going to use document.getElementById, which is going to always return a single element by ID, a single element by ID. This is by far the fastest and most efficient way to retrieve a reference to an element on the page, right? Because there can only be one ID. The browser is smart enough to say, hey, I'm going to create an index of all these IDs in here so I can reference an element by a specific ID. If you need multiple elements, right, another one we haven't really played with is getElementByClassName. Do we have any classes in here? Probably not. Let's make some real quick. So I'm going to say, that's an index? Yeah. That's that, right? Do ID content? Do I not have any classes? Sheesh. Let's class equals card, right? And we'll say p class equals card, right? So document.getElementElements by class name takes just the class name by itself. So if I put card in here, right, it's going to give you the HTML collection, again, not an array, an HTML collection that has those elements that have the class of card, right? So I've got this top one, div ID email card, and then p card. So getElements by class name takes just the name of the class, right? I think a more useful, right, rather than writing getElements by class name, is to use query selector all, and then being able to put in a CSS query selector. So card in this case is going to give me every element with a class of card, right? And if I wanted to be more specific, right, I could say give me the ID of card, right? So there is a div card element. Or I could say, give me every table element, table cell. So query selector all is a very useful function for writing code that is going to be a little bit cleaner for when you need to reference elements by any query selector that you have on your page. If I'm going to write code, I'm almost always going to use either query selector all or getElementById. I'm going to write a specific element that I want to reference. I'm going to get it by ID. I'm going to return it back. Or I'm going to use query selector all. Now there is another one, query selector. I put in TD. This is going to return just the first one that matches that query selector. just the first one. So, I don't find query selector all that useful, right? If I was going to, for example, query the card element, right? That's going to show me one element that has a class of card, but we know that we have multiple, right? And so I generally don't use query selector for anything, but I will use query selector all pretty frequently. These are all just different ways to get a reference to an element in JavaScript. Right? Just like the DOM when we were going through it with document.all, document.body. We're just trying to get, hey, the HTML says this, give me a reference that I can use in JavaScript, right? In our example here, let's get document.get element by ID, email. What's that one? It's in here somewhere. Yeah, it's this top element right here, right? The whole reason that we do this is because we want to save this to a variable so that we can do things with it, right? So we can say like EL equals, right? And so EL, now I can do all the interesting things I want to do in JavaScript. I can change the value of the code. I can say, hey there, right? I can style it. I can add borders. Right? Anything you can do in your page, you can do with JavaScript, and you get there by getting a reference to that element in the DOM, in the document object model. Okay? So the element exists, JavaScript knows it exists, we need to get to it. We need to get a reference to it so that we can start, calling code, right? I could do document.get element, query selector all, and we'll say, every TD that's in this page, right? These are our table cells down here, right? This is the start for us of being able to iterate through and change properties on everything, right? We could say TDs, right? And then we can loop through it for var I equals 0, I is less than TDs dot length I plus plus, and then we might want to just say TDs I dot style dot background color equals purple. Right? Changing all of those elements in one big swoop. Now we're using silly, like, changing the style background color is not the primary purpose of our JavaScript here. If I just wanted to make these elements purple, I would just write this in CSS in the first place and call it a day. We're doing this to show that, like, if I was to link this to a button, like, and say, hey, when I click this button, I want these to do something else, right? This is how we do this in JavaScript. We have to grab a reference to the element we're going to do something to, and we're going to have to update it with values. Let's go to our forms page. Maybe we can show this off a little bit easier. All right? So we have this form, right? It has some content in here. I have a button that has nothing in it, right? If I was to inspect this button, let's see what we call this. Oh, I didn't give it an ID. Let's pull this up. Let's give it an ID here. ID equals my button. Okay. Do something. I'm just going to have it. So right now this button does nothing. I'm going to write some code here real quickly, and I'm going to say, hey, when this do something button is clicked, do something. We'll figure out what we're going to have it do in a second. So I'm going to get a reference element by ID, my button. Right? I'm getting this element, and now I'm going to add event listener, which we haven't learned about yet, but we're going to. Add event listener, click, and then I'm going to say when this button is clicked, I'm going to take the value of, what do we call this? Inspect. Oh, let's do this color, right? We got colors in here. Right? Inspect. Select options. Right. So when we select, when this button is clicked, whatever the value of select options is, right? Select options. I'm going to I'm going to grab that color and set the background color of the page. Right? So when we click this button, I'm going to say document.getElementById, select, what did I call it? Select options color, dot value, maybe. Let's console.log this to see what comes out when we click this button. So this is an example of debugging on the fly. I don't remember specifically how to we might have to loop through the select options, but so I'm gonna make this red. I'm gonna click the do something button. Okay, cool. Yeah, so I just gotta call the value and get it, right? So when we click this button, I'm gonna say document.body.style.background color equals, right? And then whatever the value is of this of that option, right? So if I make this blue and I click do something, we change the page. If I make this red, make it purple, purple. This is JavaScript. We are doing something when a user completes an action or a task. At least for the front end, right? This is the whole purpose of this. We want to inject some functionality into our pages. We want to make things happen. We want it to be alive. What we've been learning in weeks 1 and 2 when we were building HTML and CSS is static web development. We were just building pages. All you can do on those pages is just read it or look at pictures. There's no interactivity. There's no way to capture form elements. There's no way to be able to do something when users click buttons. Right? This is the joy of programming. This is what we do. Any questions? Do I have any notes in here that I want to talk about? Nope. Cool. All right. Let's. It's 4:40. Let's take a quick break because we're going to learn about walking through the DOM, kind of the old-fashioned way, and there's a whole bunch of really cool things that we can see out of here. So 4:40. Let's come back at 4:55. All right. So there are lots and lots of really cool. I guess they'd be called DOM traversal, right? Traversal means to move and migrate your way through the DOM. Methods and functions and properties that we're going to take a look at over the next hour or so, because these are really helpful as we start trying to build applications that are dynamically changing things as we create as we kind of manipulate and work with them. So the first that I want to look at is child nodes, right? But we have where would be a good page for us to see this? Right? Let's go here. Perfect. One of these ordered lists, right? So let's grab a reference to this element. So we'll say document.query selector OL, right? That ordered list, and I'm going to assign this to a variable. So I'm going to say var my list equals, right? So my list is that ordered list. Okay. So the reference to that element is stored in the my list variable. So the first thing we can do is we can look at child nodes, right? And it's going to show each and every node that exists as a child of this node, right? And you'll notice that there's a bunch of weird nodes in here, right? There's text, there's an li, there's text, there's an li. Does anyone have any idea of what these magical text nodes might be? Okay, I'll give you a hint. The value of this text node is stored in the data attribute, and it's saying /n/t/t/t. Go ahead, Karif.
No, I was just going to take a wild guess, but since you started, I'll let you finish.
Yeah. So when we write this code, right, child nodes is going to contain every element, every node that exists inside of this element. But if we were to take a look at this inner HTML, right, you'll notice that these new lines and these tabs are in between the elements that are inside of this element, right? Because we've got white space in here. So in between our li and our next li is some actual ASCII text. It's the new line character and it's the tab character and the tab character, right? It's the same as if when we view page source, right? And we look at this ordered list, this is the first text node, this is the second text node, this is the third text node, on down the list. So child nodes, has all of the nodes that exist in here, right? If we were to look at, right, my list 1, right, that's my list 2, 4, my list dot child nodes 1, right? This is our LI. If we look at the child nodes of that, right, you can see that the only thing that is inside of child nodes is the single text element that has the word wake up. That right there. So child nodes has everything. It has HTML elements that exist inside of it. It has text elements that exist inside of it. It's how you can kind of traverse the entirety of the DOM, right? Child nodes is a little bit more complicated because you have to filter out any of these text nodes. But if you needed to get access to the text of one of these text nodes, right, 0, that would be the way you can navigate to that specific element, right? We could have also let's put an ID on this, right? So we'll say ID list item 1, right? And let's call this equals ordered list 1, right? So that we can continue to play with this. So let me grab my list again. My list 0, child nodes 1 is that element, right? I could have gotten this by going through child nodes like this, or I could have simply said document.getElement by ID list item 1. So you can see how there are multiple ways to get a reference to an element, right? I can do document.getElement by ID to get that value. I could have done document.query selector OLLI to get the first LI of that ordered list, right? This is a CSS selector. Or I could have gone through the child nodes and said, hey, give me the first child node that is not text. The first child node is the new line in the tab, right? The new line in the tab. But the next one is our LI, and it has a if it was a text node, it would have a data property, but if we look at its child nodes, right, 0.data, it has wake up. There are lots of different ways to go through this DOM, through getting to the elements we want, changing the values of it, right? This element is, for example, is our list item itself. So just like with any other way we reference a document, right, we could say style.background color equals pink, right? It's just other ways. All of the things that we're going to discuss today are techniques for how to find the element you're looking for and how to do stuff with it. That's child nodes. There is also, if we look at my list, a .children. And that is returning an HTML collection. Child nodes, if you see, returns, my list.childnodes returns a node list. So HTML collection is returned by children, and you'll notice now that there's only 4 elements in there, only 4, and all of those magical text nodes are omitted. So when you're wanting to get just the elements that exist inside of an element, .children is probably the best way to go. Right? .children. Because now, children 0 is our first element, children 1 is our next element, children 2 is our third element, and children 4 is our last, children 3 is our last element. Right? You see that it's highlighted up here? This is generally, right, when you're writing JavaScript code, you will use the .children function to loop through all of those elements and do stuff with them, right? So if you wanted to, for example, let's pull up some code here, right here. I'll write it right below our ordered list, right? JavaScript. Type equals text/JavaScript. Okay. If I wanted to loop through all of those elements, I could do document. I'll do var ol equals document dot get element by ID ordered list 1. Now what I can do is for var l in. All right, let's do this. For var I equals 0, I is less than ol.children.length I plus plus. Right? So now we're looping through those children, and we'll set a breakpoint here so we can debug and step through this. I can say ol.children I style background color equals purple. Okay, and let's just start the debugger here. Debugger. And so now you can see it's paused in the debugger, and if we were to run, right, you're going to see, right, children.length is set to 4 here, right? I is 0 right now, and if we step into this, you'll see, if we scroll down to our list, right, each and every one of these is going to be turned purple in order, right? Because we've looped through every element in that ordered list, and we got those list elements by calling the .children property of that ordered list, right? So think of it as in terms of like the reason they picked children here is very similar to like why we name these children, like, so this is the parent, the ordered list is the parent, and the LIs that belong to it, the LIs that are inside of it, are its children. Okay. Let's turn off debugging. So just like, as I'm sure you'd imagine, right? So my list equals document dot get element by ID ordered list 1, right? My list is that ordered list 1, ordered, right? So my list dot children 0, let's just look at the first one for example, has a dot parent element, right? The parent element property that is the ordered list above it. And you can go all the way up to HTML just by chaining parent element together. Parent element, parent element. Now I'm at the HTML. Just like if I come from the HTML, right? I'm at the HTML element right now. I can do child nodes, or children, 0, children, let's go 1, so we're getting the body. And then we do dot children 1, that's going to be our H2 up at the top. Right. Dot style, dot background, color equals we can navigate up and down the entire HTML document by combining dot children and parent element, right? This is the super old-fashioned way we used to write JavaScript before we had beautiful query selector functions and things like this. We would actually have to loop through nodes and get to the spot we wanted to be. Sometimes, like this is obviously an extreme example. You should never probably write code like this. But what you will often do is take an element and then loop through its children and do something to them. Or, maybe a great example is if you could have a button in here. Let's make a button. We'll do input type equals button, ID equals finish list, right? And we'll say value equals complete the list, right? So maybe you're building an application that is like a, I should make this not be purple, right? So this is like our list of things to do today, but we gave ourselves a button that says, finish every item on this list. Okay, so what we would do is we would write some code using an event handler, which we haven't really talked about yet, but let's just say, here, let's do it this way. I'm going to say finish the list, right? And I'm gonna come in here and say on click equals finish the list, right? So it's going to call that function when we click this button. So what I will do is I'm going to grab this code, okay, and then I'm going to simply loop through it for var I equals 0, I is less than ol dot children dot length I plus plus. And now I'm going to have it so that it changes the style to have these bees struck through, right? So I'm going to say ol dot children I dot style dot what is it? Text decoration. Text decoration strike through, maybe. Not sure if this is right. What is the? I always forget this because I don't use it ever. Let's see. Text decoration. It's not text decoration. It's font style. Strike. Let's look this up. CSS strike through. Text decoration. That's what it is. Oh, line through. Sheesh. Line through. Right, so now go to our page. Right, I've just completed the list. I've made everything individually be struck through. Dot children is great for this type of thing, where you know the element that contains it, but you don't know necessarily how many elements are inside of it. Right? If there was, right, we wrote 3 lines of code here, really, like the item itself, and then all of its children is being struck through as a loop, right? But if this was an actual product where this could maybe have any number of elements on this list, like dream peacefully, and maybe like a midnight snack, right? This button will still work because it's looping through any number of children. Any number of children. Any questions? No. All right. We kind of talked about children of children, right? So like, when we were playing with our code, right? If we were to take document.body, right? Has children, right? Let's go to this page. Document.body is an element that has children, right? And so if we went to our ordered list, for example, that's what, like 7, 12, 11, 10. Oh gosh. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There we go. So the body element has a whole bunch of children, and then the ordered list itself has all those children, right? So we can children our way down to the, to any element on the page. Children of children. All right, first child. That's another useful one, right? Let's go through. Wrong page. Let's close that page. It's gonna drive me crazy, right? So here we are on our ordered list, right? We know that children gives us a full list of all the elements, right? And so we could always do children 0, right? That's the first element. But there's also a first child property, first child, right? And the first child here is that text node that is inside of it, right? Text node that is inside of it, because child is any one of those from the child nodes, right? Child nodes. That first child is this text. There is also a first element child that will give us the first element that belongs to it. Okay, so for whatever reason, if you ever needed to get there using first child element or first child, right? First child element is the exact same. First child element. First element child. First element child is the exact same as if you'd written children 0. Okay. Child nodes 0 is the exact same as first child. Same. What's our button called here? Finish list. Why would you need to get first child? The reason is, that's a bad example. So let's look at our first element child. Right. Dot first child is the text, right? So first child is the text of the element, right? So it's useful for paragraph tags, text areas, any element that is expected to just contain words. First child will give you those words, right? But when you're an element that has other elements inside of it, you probably want to skip the children because most of the time we're not putting text inside of our ordered lists here, right? Like, even though we have tabs, right? This is considered the text node, right? You probably would not put in like, hi, these are words, right? It's showing up in here, right? So now if we looked at first child, right? That's the text that's there. That's a text node that was created. But you would hopefully not write an ordered list that has just random text sprinkled throughout it. Ordered lists should have list items. That's what should be contained inside the ordered list. Does that make sense? But as you see, our browser successfully rendered this text. It's just not good form. Like, why have random text in here? Ordered lists, unordered lists, they're supposed to have list items. Child element count. All right, this says 6. This is another way, this is another property of us essentially saying children.length. Because children is an HTML collection, right? It's kind of like an array that has all of the elements that were in that list, children, and it has a .length property. Or we can say child element count. Both are doing essentially the same thing. Now, this one, child element count, is probably faster than doing .children.length, because when you do .children, it is creating an HTML collection and then running the .length property on that HTML collection. But in the terms of being like a good software developer, I would probably never use child element count. I would probably almost always grab .children, because I'm going to loop over it, right? And then it has a .length property. So when I'm writing my loops, I almost always would, probably not even do it like this. I would probably say, give me my document.getElementById. I'd probably do something more along the lines of, give me my li's is the .children of that, and then I would say li's .length. And then this would be li's I style text decoration. So lots and lots of different ways to skin a cat, especially when dealing with JavaScript and the document object model. There's lots of ways to navigate to elements. There's lots of ways to loop through elements and to interact with their children and their parent nodes and things like that. This is kind of the creative aspect of programming that I find so fun, is that you can write the code in a way that makes it cleaner and clearer as to what your intentions are. I almost always am going to want to prefer to use like a .length variable here, because I'm going to use this same thing even if I'm writing code for arrays, or even if I'm writing code for object, right? When I'm writing my loops, all my other traditional loops are going to use a .length property. So why would I ever be happy with, document.get? Well, let's change this back to how it was, right? OLs. OL. ol.children.length to me is going to be closer to what other code I'm writing rather than saying ol.child_element_count. Right? They do the same thing. This is going to still return 6 regardless of how I get there. But if all the rest of my JavaScript code, looping through arrays and looping through other types of elements, is going to use a .length, why would I ever use this? It would make my code stand out here and be like, what does that do? And it would introduce possibilities for me to get this wrong, right? Like, what if I said children element count, right? That's not valid. That's going to return nothing. But if I don't use this often, it's hard for you to remember, like, oh, is that the way it's supposed to be spelled, right? Like you even saw when we were typing in the console, I would type in first child or first children, right? Swapping words around for things you don't use often is pretty easy to do. So I'm almost always stylistically going to say, .children.length, because I use .length for everything else. Any questions about that? Go ahead.
Yeah, so what you're saying is every coder has his own style. So you can read someone's code and know exactly who wrote it, essentially.
Yeah, essentially. And then there's an added caveat of when you go work in your jobs, when you're working in a company, every company is going to have a different style guide as well, or they're going to have a different expectation for how you should write code. We're trying to present to you that, like, there are lots of different ways to write code. None of them are right or wrong, so that you don't get stuck in a mindset of, like, I have to do things this way. When you're writing just for yourself, yeah, you can write code whatever way you want. I'm going to encourage you to pick a style and be consistent, because that's, to me, the most important thing. But when you get to your job, like, some companies tell you to write code this way, some companies are going to tell you to write code a different way. Just go with the flow.
Got it.
Mm-hmm. But there are lots of different ways to get there. And so sometimes, like, a lot of the reason that these different ways to do this exist is because sometimes you need to write code to be able to access the text nodes, right? Child nodes. If you have LIs and you want to be able to get, like, so here's an example, right? Let's put in strong, drink coffee, strong, right? Where are we at here? Children, yeah, good. Children on. That's the one that has elements inside of it. If I just go children, right? You can see that it has an HTML collection there. It's got a strong tag. But I really want the text of that content, right? So if I do child nodes, right, you can see the text, and then the strong has text as well, right? It has information in here. So if my element sometimes has other elements inside of it, you have to be able to know that children is just going to give you the element. Child nodes is going to give you the element and the text. Right? Child nodes is going to give you 0, drink, and then it has a strong element, which has a child, right? Drink coffee. Because the DOM, the whole purpose of the document object model is to represent in JavaScript the HTML of our page. So this complicated path to get all the way to the word coffee inside this text is essential to letting you know what the browser is doing, right? And we could have gone up, right? We could have gone here. Child nodes, 0, child nodes, right? Right. So this is our element. This is that LI, right? We have other properties, right? So you've seen me use inner HTML, which is going to show you the HTML that exists in here. We also have an inner text, and we're going to talk about that later. If you just need the text content, ignoring all of these tags altogether, right, there's an inner text. Now, the problem with inner text is that right now you see that this coffee is bolded. If I say inner text equals drink, diet, Coke, right, I lose that bolding. If I was to put HTML in here, strong, drink, diet, Coke, strong, right, it's going to literally put the tags as text in here. So we have to choose, when we're accessing these properties, inner HTML, right, which one of these properties to use that will actually cause this to render or do what it is that we're trying to do. So we're going to keep talking about inner HTML and inner text here in a second. But this is like navigation up and down. So when you're at an element, when you have a reference to a specific element, right? Parent node goes up one level. Children is an array that goes down, right? Because there's all, an element can only ever have one parent node, right? Because it's going to be contained inside of an element, but it can have any number of children. And we kind of talked about that. So we talked about parent node and parent element. Let's see. Let's find our li. There we go. So here's our second li, right? It's that one right there. And if we go style dot background color equals pink, right? So this element is that one right there. There is also a next sibling, right? Which in this case is text, just like the other one, right? Because it's those tabs, tabs, tabs. So if we were doing child nodes, right? This is the next sibling in that child nodes array. But probably more useful is the next element sibling, which is going to give us the next li down the chain, right? So I can navigate through this, right? So then this one has a next element sibling, which has a next element sibling, right, on down the list. So it's just going to kind of give us the next one. A sibling is an element at the same level as itself. Right, so in an ordered list, for example, right, this is child number. So from the context of an ordered list, these are all of its children. From the context of the children, right, so if I'm looking at it from the perspective of this li, the next element sibling is right here. This one is right here and right there on down the list. They all have a next sibling. This is the next element coming up. They also have, right, if we set style dot background color equals purple. Right? They also have a previous element sibling. So if you need to go back up, right? Previous element sibling. Dot previous element sibling, right? So on up and down the chain inside of a node. Now let's say we were at the first one, right? Children one. Right? Oh. Let's take all this out. Previous element sibling. So now we're pointed at the number one element here. If we call previous element sibling, and there is no previous element sibling, right, we get a null. Same with next element sibling. If we're at number 6, midnight snack, next element sibling, and then we call it again, next element sibling, right? It's going to give us null. So because it's giving us null, we can write code to just loop through next element siblings. So we could simply say, right, let's make it happen on the button click here. So we know that we can loop through for var I equals, let's get the var ol equals document get element by ID ordered list 1. Right? We know that we can loop through the children of this simply by saying, ol dot children dot length, right? I plus plus. We can loop through it this way, but also we can write a different type of code if we want to just say, hey, we're going to start at the top one. Here, let's do it like this. I'll show this off. Ignore the document.get element by ID ordered list 1 dot add event listener. Okay, click function ev. Right, we're going to talk more about events later, but I just want to kind of show off what we can do with this next element sibling or previous element sibling. Right, so let's say whenever you click on a list item in here, right, it's going to strike through all the ones above it. Okay, we want to say, hey, if I click on Dream Peacefully, right? If I this is my to-do list, and I come in here and I say, hey, if I click Dream Peacefully, that's the step I'm on. Everything else is done, right? So that if I click on the top one, it strikes it out. If I click on this one, it strikes it out. So we want to have this so that we click on an element, it's going to strike out all the ones above it if they're not already struck out. So we're adding a click event handler to the listener. So I'm going to say I'm going to take the current. All right, so I'm going to say var el equals ev dot what is it called? Event target. Target. There it is. So event target. When we learn about events later this week, right? This click event handler gets an event object. The target is actually telling us which of these events we click on, right? Because we put the event handler on the ordered list, but it's going to tell us which one was actually clicked on. So I'm going to simply go while el dot previous sibling. How would I want to do this? I'll do it like this. Var el equals previous element sibling. Right? Oh, it's prev. Oh, it's previous. So while prev. So I'm going to loop through each and every one of them. I'm going to say prev dot style dot text decoration equals line through. Okay, and then I'm going to simply say prev equals prev dot previous element sibling. Right, so it's going to loop through as long as I have a previous element sibling. I'm actually probably going to start with prev equals el. Right, I want it to start from the original one I click on, right? So now if I come in here and I click sleep, right? If I click wake up, drink coffee, work, sleep, dream peacefully. But if I click, hey, I finished all these, but I didn't actually click them, I can start there and it's going to click all them all the way up, right? And we did that, right? If you ignore the fact that we haven't really spoken about event handlers yet, what we're saying is, hey, as long as there is a previous element, a previous sibling to myself, strike it, line through it, and then give me the previous element to that, right? So that while this is looping, because when we finally reach the top, when we finally reach that first element, previous is going to be null, and null is a false value. I could have also written this in the boring way, right? I could have said, I don't know. This code to me just looks cleaner, right? Because if I had to write it as a for loop, I'd have to first start at 0 and then work my way down until the code matches, until we see, hey, am I at the spot I'm supposed to be? So I'd have to check to see if ev target equal, right? So let's do that. So I'll say for var I equals 0, I is less than, let's grab ol equals document dot get element by id ordered list 1. And so we'll say ol.children.length I++. And then we would say ol.children I.style.background color equals text decoration equals line through. And then we want to check so that if we are at the element we want, right? So we would say if el equals ol.children I, right? If we reach the element we clicked, leave the loop, right? Because we don't want to loop through every child, so we would say break, right? Break leaves the loop. So now this code should do the same thing, right? If I click there, it goes to there. If I click here, it goes all the way down to 5. So this code is like a traditional for loop, but I think, personally, that when we're talking about elements like this, when we have this specific type of use case, is that the while loop syntax is much cleaner. Right? You can see how it's shorter lines of code. It's maybe more apparent what's happening. We also don't have to count anything in here. We can just Simply say, as long as there is a previous sibling to strike through it. Both implementations do the exact same thing. But stylistically, to me, personally, this one looks way cleaner. Right? This versus this. They're exactly the same. It just operates differently. Right? And we can even run these together. You can, let's right, so let's run our debugger here. Debugger. And let's step through this and see how it works. Right? So I click this, it starts the debugger. And if we step through this, right, while previous right now equals this li, you can see it highlighted. Then we step into the next one. We're saying, hey, strike through it, which it will. Then it's going to previous element. And then it strikes through the previous one. Now it strikes through the previous one, and now previous element is null. So the next time it tries to run this loop, right, previous is null, it leaves. Now it goes to here. Right, let's look at the other loop, right? It's the same logic, but just going from two different directions. Right, so we're getting the ordered list here, and then we're saying, hey, for var I is whatever, right? There's 6 elements in here, it's going to 6. It's saying, hey, set the first one. All right, let's reload here. Let's copy this out. So you can see it happen in real time. And I'm gonna click here. Boop. Cool. So I'm going to hit F9 now instead of clicking that over and over again, right? So that's for var I is 0. I is 0 right now. Children.length is 6. So it's saying, hey, set that first one to strike through. And then it loops through, and it's checking to see, hey, does this match this one? And if the answer is no, it loops again until it gets to the one we clicked, right? Because you can see the EL is our event target. That's that one, 5. And it's checking to see the current one, right? If that matches. And if it doesn't, now it does, and now it's going to break out. It's not gonna do number 6. And now we're done with the code. So sometimes using these types of DOM manipulation functions or properties, where you're getting previous sibling, children, next child, you can write better code if you choose a certain version than another version, right? Like, this is far easier to look at and work with, to me, than looping through all of the elements individually and working our way up and then comparing, right? This adds a whole bunch of extra steps. This is saying, every time this loop runs, check this element against this element, and then do something else. This one doesn't even worry about that. This implementation says, wherever I started from, strike that through, and then go to the previous one, and strike that through, and then go to the previous one, and strike that through. And we could, just as easily, have said, next element sibling, right? If we wanted to change this logic, next element sibling. So now this, the debugger's gone, right? If I want to make it go down the list, right? Oop. I broke, it's because of this. We got 2 loops running, right? I'm going to actually make this ev.target. So we start at the one we're at, right? So all we had to do to change the direction is just change the word next to previous. All with one line of code. Hopefully that demonstrates the value or the importance of knowing some of these elements, right? Knowing some of these properties for how to move around the document object model, because it's incredibly important, especially when you're dealing with user specified input. A great example, and the reason we kind of use this as an example here, is that, like, a lot of software engineers will generally build a simple product like a to-do list application as the easiest first thing to put on your portfolio to show off that you understand all of the basics of building code, right? You should be able to have an input right here that will add an element to this list, and you should be able to strike things out and say, I'm done with this. This is it's one of those types of programs where, like a to-do list app, where you can build this in like 3 or 4 hours and have something really nice and polished that you can put in your portfolio. And then that same technology, when you go and you learn a new programming language or you learn a new back-end framework or something like that, you can go and write a new to-do list app in that new technology because the concept is universal, right? The rules are very simple. Display a list of elements. When I add a new element, it adds it to the bottom of the list. When I click it, it removes it or strikes it out. The database, the data model behind the scenes, if you're going to actually hook it up to a database, is very simple, right? You can just have a list of IDs where it says this is this value. Maybe you want to get complicated and add a due date for things. It's a very simple app to understand and explain, and it's really easy to use it as a kind of like Rosetta Stone of learning a new language, right? So to-do list apps are great, and this type of knowing how to navigate in the DOM like this from the front end perspective will be the same, because you're going to always have to write JavaScript to interact with whatever backend language you're writing to support this, right? We're going to learn Node.js in the backend, so it's still JavaScript for us. But if you were going to write this in PHP, your HTML and your front end is going to be the exact same in all of these versions. And then all that happens is when you click on one of these elements, right, you would have some request to the server to mark items as complete, right? So you'll have, we're going to learn about XML HTTP requests. We'd say new XML HTTP request, and then it'll be like save item, right? And then whatever arguments you need to pass into it so that we can store this on the server. But interacting on the web page level, on the front end, is incredibly important, because how you write your code will be the difference between you being loved on your team because you write good, clean code that's easy to read, versus you being like the one where they constantly have to nudge you in the direction of like, it would be better if you wrote this code like this. Knowing what way to write, what style to write, knowing what kind of syntax to choose from here is one of the things that will come with time and experience. So we don't expect you to be perfect right off the bat. And even when you get to your day job, when you're working in a team environment, you're going to get reviewed, and they're going to say, hey, this code worked, but it'd be better if you wrote it like this. And you're going to take that feedback and hopefully, think of it like learning a language as a kid, right? You start out knowing a few words like mama, papa, and daddy, and apple, and juice. And then you start being able to build more complicated sentences the longer you experience that language. This is the same way with programming. We're teaching you words right now. We're teaching you how to string together sentences. But over time, over practice, you'll get to become an author. Or you'll get to become like, somebody that you actually want to read your code. Cool. All right, let's look at creating elements. All right, so in that same vein, right, if I have an input in here, let's say input type equals text, name equals, what are we going to call this? New item, ID equals new item, right? Autocomplete, none. Turn off autocomplete. And then I'm going to put a button in here. Input type equals button, name equals add item. Okay. Wait. ID equals add item. Value equals add item. Right. So I'm just adding a simple input that we can see above our element here. Right. So I've got a place I can type in some words. Now, I could. Right. We can write this a couple of different ways, but we're going to take a look at the official DOM way to do this. Right. So I'm going to add another event handler in here, just so we can keep playing. Get element by ID, add item, dot add event listener, quick function db. Right. I need to get the value of this new item. Right, so I can do that here. I can say var new list item equals, and I could say document.getElementById new item dot value. The dot value property of JavaScript of an element on our page is going to read whatever the value is of this input. Right? There's an attribute in here called value. Right? And if we put something in here, Eric. Right? Eric is going to be the actual value of what's in this text box, but we can access that with the dot value property when we're on that element. So new list item right now, with this page being loaded, if I click this button, would be Eric. Right? If I click this button, that would be Eric. We can't. We'd have to console.log it or something. Console.log new list item. Click. Right? Eric. So let's take out this value. Let's take it out. All right. So what we want to do, let's comment this out as we go. So we want to grab the current value of the text box and then add it as an item to our ordered list. Okay? So this line of code satisfies that requirement. Okay, we're grabbing the new list item. We're saying, hey, give me the value. Then we want to add it to our ordered list, right? It's got some words in here. We might even want to, right, check to make sure there is a value in here, right? Because what we're going to show off is that if I click this button and I haven't put anything in, right, it's just going to make a whole bunch of empty list items. So I'm going to show off two different ways to create elements, right? The first is probably the easiest, right? Because we know that we have a document.getElementById ordered list 1, right? If we were to, right, we have an inner HTML, right, that has list items in it, right? So if I was to come in here and say inner HTML equals, I'll just copy it again, right? So if I take that inner HTML and I add a new list item, something here, right? It's going to keep adding list items to that inner HTML. And I can go on like that forever and ever and ever. If I wanted to add an item to the top of that HTML, right, then I would just change the order at which I'm adding this together. We're saying the inner HTML equals this new list item plus what was in there before, right? So if I said li top li plus document, so now this is going to go right above wake up, right? So that's the easiest way. Document.innerHTML, the .innerHTML property of any element that is an HTML element on our page will let us write HTML inside of it. So I could very simply in here come in here and say, document.getElementById ordered list 1 inner HTML equals, and let's say li plus new list item plus li plus, and then let's just grab the, right? So we're gonna, whenever we add an item to this list, it's going to add it to the top of the page, to the top of this list. Eric. Sleep. Okay? We can just keep adding things as often as we want in here. Now, there's another thing that I noticed, right, when we're thinking about building an actual application here, is that when I type this in, I would maybe expect this to be cleared out, right? So let's do that. So once we've added that value in here, and we can say clear out the element. So we'll say document.getElementById new item, right? So this is our input element up here, and what we're going to do is instead of getting the value, we're going to set it. We're going to say value equals nothing, empty string. So now if I type in ASDF, right, now it's cleared out each and every time. Now, we were talking about, hey, we took a comment, check to make sure there's a value in here, right? If I click add item, well, that's probably not good. That's bad behavior, right? We're adding a bunch of blank nonsense. Maybe your cat came and stepped on the keyboard. Right? This is adding content to our page that we don't want to. So what we can probably do is even just shortcut this. Right? We can say if new list item, right? We can put all of our code that we're actually doing in here inside new list item if it's there. Right? Oh. 10. So now it will only run if there's a value in here. Right? ASDF works in perfectly. If I click this over and over and over again, nothing goes in. Now another thing to be aware of is that if I put in blank spaces, right, that counts as a value. So we have another thing that we can check here. We can say .trim, which is a method of a string. It's a method that exists on string objects that is going to remove all white space from the front and back, right? So if we were to run this, and we type, okay, none of that goes in. If I type in ASDF, you'll notice that if I hit a bunch of spaces and type in ASDF, okay, there are spaces there, it's going to trim those off. If I did not, well, but it does not remove spaces in between, right? It's just trimming from the front and back. Okay, and if we were to, still have the close things out code working. That's beautiful, right? So now we're getting really close. Like this is actually doing something, right? And that's one way to write it. We want to take a look at, right? So this is the inner HTML way. There is another way to make items. So let's before we move on, because it's important that, so we have, when we were checking the new list.trim, right, we could have also kept this at the same level, right? So now we're saying, hey, if not new list.trim, so if there's no value, break out. So we'll say break. Or we could have said return, right? Both are going to do the same thing. And what this is doing is, instead of putting all of our code inside of there, this would be like, this style of writing code is called like the exit early principle, which is as soon as you know you're not going to be able to do the thing you're doing, just leave, just return out of it. This is the exit early version. So oftentimes you'll see code written like this where, at the start of a function or at the start of some code, you'll check some things and you'll return out if it's false, or you'll leave if it's incorrect, or there's going to be some kind of problem. This would be like the exit early version. It sometimes makes your code a lot cleaner in terms of readability. Because you can imagine if there was hundreds of lines of code in here, being able to start at the top of your function and to have all of your checks up front to say, like, will this even work to begin with? Do I have the right information I need? Is better than having a whole bunch of nested if blocks where you've got code inside a code inside a code on down the list. There is no right or wrong answer. It's a style choice again. But I personally prefer the exit early type of structure. It makes it very clear to when you're writing functions that are expected to be read by other people. I can start at the top of the function without knowing anything about it and start to see what are the conditions that will cause this to be not executed. What am I actually looking for? If you put all of those at the top, then it's very clear, what is important and what is not. All right. Any questions about the exit early concept versus the, put all of your code inside of the function? And you'll notice that the exit early is the exact same thing as as what we were writing before. All I did was I took the true condition, right? So if there's some value here, run all this code, and I said, hey, if there's not some value here, leave immediately, return. And we could have maybe even returned something, return false, return. Maybe we can even say, document.get element by ID, new item, .style, background color equals pink, right? Like, show off that there's a problem here, right? You didn't put the, a word in. And if we're going to do something like this, then we probably need to say, like, every time you click this, right, just by default, set it back. Document.get element by ID, new item, .style, .background color equals white. Right, so if I put nothing in there, it goes pink. If I type something in, it goes back to what it's supposed to be because it checked a value. But as soon as I don't have a value in there, hey, it's got an error. So that is a very common sort of flow for front-end development as a developer. All right, so we've been talking, right? So this is the .inner HTML method of creating elements. Let's take a look at a more traditional, more formal way of adding HTML to our pages, right? So let's take this out. So there is a special function that exists in the document called create element. So I can say var li equals document dot create element li. Okay. This is going to create an li element, right? If I return this, so let's console.log so we maybe see this off. Right? Console.log is that it's creating an empty li element that is not on the page anywhere. It just exists in JavaScript only. But this li element is a full element, right? So all the things we can do with an li, right? We can say li.style.background color equals FFF9, F99, right? Like a light yellow, right? And if I type this in here, right, you can see that it's creating this element entirely inside of JavaScript and letting us do things to it, right? So we can do li.setAttribute ID equals new element 1, right? Anything that we can do in JavaScript to an element, we can do to these fake ones we created. But now, we want to be able to add this to the page. And the way we would do that is we would say document.getElement by ID ordered list1 append child, and then we paste in a, you see that the argument here in this little pop-up is it's expecting to get a node. And a node, in this case, is an element, right? So any element that we created. So I'm going to say li right here. And if I type ASDF now, right? Well, I made the background color yellow, so that was maybe a bad choice in terms of style. But it's appending that to the bottom of the list of elements. Append child gives us that. Is there a prepend child? Prepend. Yeah. So there's a prepend, and we can put in li in there. Let's change the style to be not. It's just light. Oh, let's make this. Yeah, let's do this. Let's go back to that color, and the reason this yellow was so bad is because we can't read the font. So we'll say style.color equals 000. Right. So now, when we view our page, right, if we type in some words here, where's the color not? Color. Oh, we haven't added text yet. So the other thing we have to do, right, when we are creating these elements, is that we have to also put the content in, right? So we can do that this way. We can say li.innerText equals document. What do we call it? New list item is our variable. New list item. Okay. And so now when we type, right, ASDF shows up right there. If we use that's prepend. If we use append, right, it goes to the bottom of the list. So we can say document.getElement by ID ordered list1 dot prepend or append child y. Right? So if I put ASDF, now we're going to get one on top and bottom because I've can I save it? Why is it not? Oh, because as soon as it's I wonder why it's not working in both places. I would imagine it would make two. Interesting. Maybe if we make a copy. Let's see if I do that. Var copy equals li. And let's say copy goes here. I wonder why prepend isn't putting them in both places. That's interesting. I've never tried to do this simultaneously, so I don't know why that's not working. We'd have to test it and see what was happening. But this method of creating an element manually and then running through it like this is kind of the more old school way of adding new elements to the page. Most of the time, you're going to pick you're just going to say, hey, I need the inner HTML of this. The reason you would choose to do it this way, though, is that when you start working with more complicated element structures and more complicated HTML structures, working with HTML as a string, where you're saying, dot inner HTML equals whatever, right? Whenever you start wanting to be able to set some of these values, like the color and the backgrounds, like you're building dynamic applications, right? Now you're changing a whole bunch of stuff so that the HTML that you're writing in here is kind of ugly, right? So you can imagine if we wanted to come here and replicate this, we'd have like a style equals, background, color, and then you would probably have to escape out of this and add like color choice plus, right? So working with strings like this gets very complicated, very messy, very quickly. Whenever I'm doing anything more complicated than just adding a single element, or maybe if I had a class that had these styles applied to it already, then I'm going to probably choose this type of syntax where I'm actually creating the element and appending it to the place I need to go. Both are valid ways of creating code, or changing code on your page. There is also, right, this is create element. There is also remove element, or replace, remove, right? So if we wanted to, for example, be able to delete any of these elements, right, I could say document dot id new element 1 dot remove, right? And it removes it from the page. And I also just figured out why our code was failing when we tried to do both at the same time. Does anyone know what it is? Okay. Why is this not adding it in both places? Go ahead, Kareef.
Was it because it was removing it and adding it at the same time?
Nope. It's because we put an ID attribute in here. So IDs have to be unique, right? And so as soon as I set an ID in here, it's adding it to the top, prepending it, and then it's saying immediately after that, hey, add it to the bottom. So it's literally moving this element. If we took this out, we might actually have to try this a different way, right? So, okay. So let's say, prepend there. We could, I think it's because this element, right? So when we create a reference to an element this way, document.createElement by in this format, it's the exact same behind the scenes as us saying, hey, I'm talking about this specific element, right? I could duplicate this element. I could say var li2 equals document.createElement li.style.background code, right? So if I copied all of these lines of code, right, I could still create a duplicate li2 2. Then I can put this at the bottom. So now we're in both places because I created two separate distinct elements. There might even be like a clone method. Let's see. Var li3 equals li2 dot clone, maybe? Clone node? Yeah, there we go. We'll see if we can make a third. Document dot get element by ID ordered list 1 dot append child li3. Right, let's make li3 look different visually. li3 dot style background color equals perfect. So now we should see one up top, two on bottom, but one should be purple. Yeah, which is exactly what we have. Cool. It also did not clone. You see that it's got this argument in here. It did not clone the text node, which is interesting. So we probably would have to put in like 1 in here so that it captures that text node. I've never used that before. That's cool though. But the other cool thing about this is that as we're adding items, as we're making our list bigger, right, our code still works, right? Our click code. This is dynamic. So this is the joy of JavaScript, because we wrote that code originally just to process our list. Right? Previous. Let's change this back to previous. So as this list is growing, it still works to remove things for us. And if we were to click way down here at the bottom, it goes all the way up. We get all that for free because we wrote good code in the first place. Any questions about any of this? No? All right. It is 6:04. Let's take another break. Come back at 6:20. All right. A couple more cool document object model manipulation functions we're going to take a look at. Let's go back to our code here. Let's see. I'm going to create a style sheet for this. Let's see. Style type equals text/CSS. Cool. Style. I'm going to make a couple different classes so we can show this. I'm going to say border, bordery, border 1px solid black. I'm going to make one that's called padded, padding 20px. I'm going to make one that's called like colorful. I'm going to say background color. Let's make it like CCC, like a gray. Okay. I'm going to come in here into this. Oop, I didn't click that. I'm going to come in here into this H1. And I'm going to add those classes. I'm going to say class equals bordery, colorful, and what was the other one? Pad it. All right. So we should see, yeah, we get a little bit of padding, we get some borders, and we get that background color. If I was to get that element, let's see what query selector H1, right? So I'm going to get that first H1. You can see that the element, right, has the style, has the class attributes of bordery, colorful, and padded, right? And so if I was to use this element, let's actually store it. Var my H1 equals, right? So my H1, right? That's the element. Now there's a .class name property that will show you the entire string of the class name, right? The old way we would have to work with this element if we wanted to make changes or we wanted to do stuff to it, right, would be to come in here and, you know, maybe we would split on the empty string, right? So we turn this into an array. You know, then if we wanted to add stuff to it, we could always add class name equals, you know, my h1 dot class name plus space, and we can put in like new class, right? So now you can see if we looked at the element, right, it has that attribute added at the end. But there's a cool new method, there's a cool new property in here that makes all this a lot easier to work with, right? And that mechanism is called class list. Right? Class list is going to return a DOM token list type of element. It's like an array, just like the other ones, right? It has a dot length, but it has a bunch of cool functions or methods available to us that make it really easy to work with classes, right? So we can say add something new, right? And now if we look at class list, now it's got 5 elements, and one of them is something new. There is also a remove, right? So I can remove a class in here, remove. Okay, and I can also remove new class, right? And if I was to remove pad it, right, we're going to see our padding disappear. See that? If I add it back, add pad it, it goes back. Now, normally what you would probably do is you would check to see if there was a value in this string, if you wanted to toggle on and off. But there is a toggle function that will do that automatically for you. So paddit.toggle, paddit.toggle, right? So we can quickly swap in and out CSS classes really efficiently by using the toggle function. And we can do that with colorful, right? Pretty cool technique. We used to have to write code ourselves to do that kind of manipulation, but now it's built in, and we get this available to us for free as a method of the DOM. Still, you should be aware that if you're ever building software to support really old browsers, right, these functions might not be available, and you might have to write your own that does stuff on the class name. No, excuse me, class name string. Right? Class name equals my h1 class name plus colorful, space colorful. There's nothing magical about this. It's just nice features to the language that were built in so that we don't have to do all of this manipulation on our own. If we were to go to W3 Schools, let's see, I would imagine all modern browsers have this now, class list. Yeah, so it became available in Chrome version 8, Firefox version 3.6, but you'll notice it's available on Edge version 10, but not available at all in Internet Explorer. So if you're ever supporting an older browser, you go work for a bank or somebody that cares about, we have to support all these customers regardless of their computer, right? Some of these things sometimes don't work. And I just want to reiterate that to you. So that it's not a surprise when it comes up and, you write perfect code that works on your computer, but it doesn't work on, some random computer that your customer is using. But that's how you manipulate and work with classes. Now, we've been spending a whole bunch of time as examples in this course manually setting background colors to elements and things like that. But generally, if you keep them, if you refer back to what we were talking about, like kind of in week 1, week 2, is that style information really belongs not on the elements themselves, but in classes, in CSS, in the actual stuff. So generally, when we're writing code like we were doing earlier, making all these lists be purple and stuff, like right here, I would generally not manually put a color in here. What I would traditionally do is apply a CSS class that was already defined to say, hey, this is, I want it to use the new color, right? So let's, right? So instead of going in here and actually setting these colors here, I would have came in and said li2.classList.add new element, right? Or, some CSS class that is defined with that style. Let's take all this out. Bloop. Perfect. So now we're just going to add one. So instead of doing it like this, I would say li.ClassList.add new list item. Okay? And then I would make a new list item style that has all of those properties that I want to set. New list item, background, color, FF9, color, 0, and maybe we do font, weight, bold. Right? So now I'm using CSS for what it's good for. I'm letting my CSS styles dictate what the elements will look like when I put them on the page. This is a better way to write our code. And we would use, just simply by adding the class to those elements, we're getting that functionality for free. Any questions with that? The last stuff we're going to really go over today is all the different types. We've kind of touched on a few of these. We've looked at inner HTML. We've looked at inner text, right? Right. So if we were to look at document.get element by ID ordered list 1, right? We know that ordered list 1 has an inner HTML property that has all of the HTML code that exists inside of that element, right? There is also, as we've seen, a inner text element, which is going to have just the text content, right? It's going to remove all of the tags, but it is going to show all of the words that exist in there and any new lines or any tab characters and stuff, right? So drink coffee. You'll notice it stripped out the strong tag. There is also a text content that is going to do the same thing, but it's going to include, some of the extra formatting symbols like tab, right? So if that was important to you, right? If you were building Oh, we don't have one on this page. But if you were building, for example, you know, on our input over here, right, like forms.html, right? You know, we might have a worker or a user that has typed in big paragraphs of text, and maybe it has tabs and stuff inside of it. Using the text content option will let us preserve and strip out those values, right? So that we can store them exactly as they were written. If you're writing a text editor for someone to like be able to write a book or write a novel or something, you want them to be able to include formatting information like tabs and extra spaces and stuff. And so you would use text content to preserve that, right? And if we went to what's this? Let's just document.getElement. Let's do query selector text area. Okay, it's that one. Dot text content, right? We can put information in here. We can say, you know, hello, and then we can do a /n/t. This is a new paragraph, right? Did I get the right one? Inner text. Oh, I don't have an ID there. Why is this not working? Inspect. Oh, it was put in. It just didn't update in here. That's weird. Huh. Interesting. I don't know why it didn't update. What if we do it by value? Text area value. Oh, by ID. Query selector text area dot value. Oh, maybe it's just because it's a text area thing instead of a. Yeah. Okay. So this is a text area specific thing. Because it knows that it's a part of a form, it wants us to use the dot value property to set the text content. But if this was a paragraph tag or something that was an actual HTML node, let's see. Inspect. Let me grab one of these. Oh, we got it. Cool. Document. Get elements by class name. Card. Let's go to the second one, right? And then we can say text content equals, right? You can see that this one has a whole bunch of new lines and tabs. If we were to come in here and say dot style dot white space equals preserve, pre. Yeah, perfect. That is what it looks like if the white space was being preserved and displayed as it was behind the page, right? So if we were to even then go in and say, background color equals maybe like that. Cool. Oop. Let's use string. So this is the representation of that white space that we have behind the scenes. So if we wanted to, right, we could say text content equals, hi, hello, /n/t/t, right? Double tab. Right? And you can see that we have two specific tab characters in here. And you're only seeing this now in this paragraph tag because we told it to use the CSS style rule of preserve white space, right? Because otherwise, if this was not preserve white space, then the default behavior is that white space is collapsed. But you can imagine if we were building ourselves, a story writer or a typewriter or a text editor or something like that. We care about the tabs, and so when we display it to the user in the browser, we would want to make sure that we're updating the text content correctly. And we could even write code in here to turn this into a text editor purely from JavaScript, even though it's a paragraph tag, right? So I can come in here and say document. Let's give this element a let's say editable, right? Let's give it an ID. So ID equals editable. Great. So I'm gonna write really quickly document dot add event listener key up. Right? So anytime there's a keyboard press, I'm gonna take that key up. EV. And we'll play with this a lot more tomorrow. Let's take a look at the event thing. Keyboard event, great. Key A, oh, key. And so if we do, okay, cool. So we can do this. We can say document dot get element by ID, editable dot text content equals plus ev dot key. Right? So as we add this content in here, it will, as we type on this page, right? We can see here that we're editing our page, right? Let's come up and let's make this look nice. Editable. We'll say white space preserve. We'll say background color. What are we going to say here? Like EEE. And yeah, good. Right? So as I type on this page, you can see, oh, it's still right? Some of the, like if I hit spacebar, it's moving down, but it's still typing, right? So I would probably want to do, well, we've gone this far, we might as well keep going. ev.prevent default. Right, so, oh, if our page wasn't so big, this wouldn't be a problem. But anyway, you can see how we can, through a combination of JavaScript and styles in CSS, we can make really interesting and unique applications that respond to the user in a way that is pretty organic and lets us build powerful things just by combining a few simple concepts that we've been learning over the last 2 weeks. Okay. So text content, inner HTML. The other thing that is interesting to note is that just like with inner HTML, let's document.get element by, well, let's do query selector. Query selector h1. Okay, so this is our h1, right? This one up here. It's got our classes on it, bordery, colorful, padded, right? We know that we can do inner HTML and see what is the HTML inside of this node. There is also an outer HTML, right? That includes the entirety of the tag. So we can go and we can say the outer HTML of this h1 is actually h2 something else, right? So now this will no longer be an h1 and will be replaced with an h2 that says something else. We can replace entire HTML tags by selecting the tag that we want to do something with and replacing it. We could do the same with our ordered list down here, right? What do we call this? Ordered list 1, right? Document.get element by ID ordered list 1 dot outer HTML, right? And you can see the entire HTML that went into that, right? Ordered list 1. I can replace this equals, let's make it a unordered list with an ID of ordered list 1. Let's just make this a blank unordered list. Okay? But our code here should still work, but now it's unordered list because we changed it inside the browser. We said, hey, that element that was an ordered list, I want to replace it completely with an unordered list. And if we look at our code now, right, that was our first unordered list, but this was the one that was originally rendered as an ordered list, but we replaced it with this new one. The Elements tab in your document, in your developer toolbar here, is always showing you the currently rendered version of the page. Right? If I was to reload this page, right, this is Elements. This is our ordered list right here. Right? That is what was there in the source code. But as soon as we start making changes to it, right, with our JavaScript, this is always going to show us the current state of where we're at. What is currently being rendered. Any questions? No? All right. Let's do some practice. What I want everyone to do for the next 30 minutes or so is I want you to start building a to-do list mechanism. So it's 6:40 right now. By 7 o'clock, have the structure of a nice looking to-do list thing, right? So we don't need the JavaScript to work just yet, but let's make either an unordered list or an ordered list and have an input element with a button so that you can create those on the page. Okay, and then by 7 o'clock we'll come back and we'll maybe discuss adding some of this functionality that we played with just today. Okay. So by 7 o'clock, everyone should have a page that looks okay, that is a to-do list program. And what we're going to do is, just to kind of set some context here, is that the reason I wanted you to make an HTML page is that for the next day or two, this is going to be our practice application, right? And so I built one during this time frame as well, and we're going to use mine as an example, but we're going to start to write good code when we learn HTML and JavaScript so that we can actually turn this into a functioning, kind of like simple little application. Okay, go ahead. Walk us through what your idea was.
All right. So my plan was to have, I was going to use the grid. I was going to have a small box up top with the title.
Okay.
My next box was going to have the ordered list, and my bottom box was going to have the input.
Okay.
But when I try to render it, and I want to make sure I was on the right page.
So you're not. The display grid, like when you say display grid, it goes on the container that has the grid inside of it. So that's problem number one, right? Your box 1, box 2, box 3 are children of the Yeah.
So this should have been here.
Yep. And then there's a couple problems in your HTML that we probably want to fix before you get too much further along, right? You have a header in here that says this is a test. All of your displayed HTML elements need to be inside of the body. So if you're going to use the header element, right, you would want to put that below, like inside of body.
Yeah, that was a mistake.
Yep. The HTML element only has two elements that go inside of it, head and body. So everything else that we want to actually have rendered goes inside body. Okay. So then you have div class container, and you've got a box 0, which has everything inside of it. So box 1, box 2, and box 3 all belong inside of box 0. Is that what you're doing? Okay. I would probably encourage you to maybe pick more descriptive names for things as your classes, and when we show off my example, hopefully that'll be a little bit clearer, so that you can write better code, both on the CSS side and on the JavaScript side and the HTML side. You're able to see, like, this is the purpose of this element. It's to do this. So I would have maybe, just me personally, called this like list as the class. So that's like your total list. And then, box 2, I'd maybe put like list title as the name there. Box 1 would be maybe the list title. Box 2 would maybe be like list itself, and then box 3 would be like list form.
Okay.
Just to give it more description, right? You can put whatever name you want in here, but when you pick generic names like box 0, box 1, box 2, box 3, it's really easy to get lost and get in the wrong spot. Cool. Very good. Does anyone else want to show off what they did?
I need like 2 more minutes.
All right. I'll give you 2 more minutes. Finish quickly.
Yeah.
Yeah. Very good, clean design. I like it. Yeah, we can definitely learn and explore and play with the dates for sure.
Yeah.
Cool. All right. Well, I'm going to share my screen because I think you guys all got the gist of it. We can all make HTML pages at this point, and how much time you spend styling something, like there's no like end result here, right? Like, you can keep tweaking it forever and ever and ever until you're like super happy with it. But the important part is, as a software engineer, right, you should get to a point where it's good enough for you to add the actual functionality and make it work. So I'm going to share my screen, and we're going to walk through like a day in the life of a software developer building a to-do list type of product from scratch. And we're going to like use some of the things we've learned thus far to have a discussion around like building real products. And so I actually took a very similar approach to Karif, where he was starting to use CSS grids. I used Flexbox, right? The idea was I have this HTML page. I want each list to be self-contained. And I had this concept where I said, I'm going to be able to create new lists as well, right? And I should be able to create as many lists as I want, and I should be able to delete them, add new items to them, and have it all happen dynamically. And so I'll just very quickly show off the code because I made it fairly easy, right? So the idea is every element that is inside my list is my top level container. That's the one that has display flex. If you look over here, right? List is display flex. And I said, hey, I want a little bit of a gap between my elements, right? So every list is going to have a little bit of padding to the left and right of it, 20 pixels. Okay. Then I said, hey, inside the list, what is going to be in there is just a bunch of list cards. All right. I made one at the end. And I gave it a class of blank. I don't know what I'm going to do with it yet, but I know that I want it to be. I can type some words in here like new list, and I click the plus sign or whatever, and this should create a brand new box and put it to the left of this, and this should always keep on chucking, keep on trucking. And then for the list, right? I made this cutesy little element. This one, when you asked for 5 more minutes, I said, oh, that's fun. I can add some cute stuff. I added a little bit of CSS so that when I hover over it, it adds a little green checkbox, right? A little green check mark. And I did that very simply using the item hover pseudo element, right? The hover event. And I also said, hey, I used the after pseudo element to add the content of a check mark and put the color to be green, and I added a little bit of margin to the left. So each element in this list gets this little check mark that only shows up when I'm hovering over top of it. So now we're at a stage as a software engineer where I'm like, this is good enough, right? Like for me, my purposes, if I'm building a to-do list app, okay, I know I can keep tweaking the look and feel. I maybe want to change the colors. I maybe want to pick custom fonts, but I could spend 8 hours tweaking the design and never get to a point where I'm like, this is perfect. But this is good enough for me to like start adding functionality and see what comes out of it. And one of the great ones that Josh had mentioned, right? So as an engineer, I might say, I'll take a comment in here to do think about adding dates, due dates, created dates, right? Like the actual implementation of this is the interesting part. It's not like what it looks like necessarily, right? Someone who cares about front-end design, or if this was something that I was launching as a product for myself, I might actually spend the full day or however long it takes continuing to tweak this and make it look pretty. But for my engineering purposes, I just want to get like this to be working as a functional to-do list system. So I have this set up right now where I've got a pretty good structure in my HTML. So now it's time to like actually turn this into a functional app, right? So we're not going to have this skeleton HTML in here anymore, right? Like none of this matters. I'll keep it in here for now while I'm playing. But I want to start thinking through like what does my data model look like, right? And so let's take some notes in here. Because we're going to actually start coding this. I'll make this smaller. Good. So let's think about it. Okay, so data model for storing our lists and items. Okay, so we're going to have some kind of object or array, right? So, what jumps to mind off the bat is like lists is probably an array, right? Probably an array. And inside this array, each list is probably a list itself, right? So we might want to have an array of objects that has like list title something. So like list number 1. And then we probably want to have like items, right, is an array, right? So each element in this to-do list is an array. And each element here, we probably want to store, we could be naive about it. We could put in just a simple string like item 1, item 1, item 2, right? And on down the list. Like this would be a good start, but I already know that I'm going to want to do some more interesting things in here. I'm going to want to store, is it done or not? Is it, we probably want to think about, does it have a due date? Does it have a created date? So I'm going to just jump right ahead because we're already smart enough to know this. I'm going to want a more complex data object here. So I'm going to make each item in my array have a, let's make it like a value, and we'll say item 1, and then it'll have completed false. We can just make this Boolean, and we'll do the same thing here. We'll say, just copy this one, type it again, and we'll just change this to item 2. So now we've got kind of a cool data model, right? So we're going to have an array, right? If we had a second one here, so it'd be like this. Okay, list 2. And it would kind of match up with this. So let's actually write JavaScript code now to have this data model be rendered on our page instead of the blank HTML that we have. So let's just copy in one of these. Right? We can copy this in to our code so that we can use it as a reference, or we could have, we can pull this up in a tab. Actually, maybe it's even easier. Right? So we can start thinking about writing our code to render this in. So I'm going to make a comment. This says render to do lists. Okay, and so we'll make a function called render to do lists. Perfect. No need to get crazy. And it's going to, inside this function, we're going to loop through the lists and make cards. Right? We've got to make these list cards. So let's maybe include this list cards so we'll know what we're talking about here. Then we will loop through the list items and make the dot list. Right? So that's really all we're trying to do here. We're going to write a function that we're going to call that is going to loop through each of these lists and say, hey, make me a card, make me a card. Okay? And we can start this. Let's just loop through this first. So I'm going to say, what do we have here? We're in the, right? So lists is our top level container. So that's the only one we care about for right now, right? We can even come in here and say, document.get element by ID lists. Let's give it an ID so we can, ID equals lists. Lists dot inner HTML equals blank, right? We're just going to clear it out. And what we probably want to do, because we are going to use this element a bunch of times, we'll say lists equals this, and then we'll, instead of clearing it out in one line, we'll say lists dot inner HTML equals blank. All right, so now when I load this page, did I load? Oh, save. Good. Oh, we have to call the function. So we'll say render to do lists. Okay, so now everything's blanked out. This is exactly where we want to be. So, right, if I took out this line of code, right, everything's back because that's what the HTML template has for us. But for now, we're just going to blank it out. And what we want to do is loop through the lists. So we get this from up here, lists. Oh, I'm going to have to, let's call this list EL. This EL, right? We can't have the same variable name. So if I create an element called list, it's just overwritten this list element, or this list argument, list variable. So what I'm going to do is I'm going to say for var I equals 0, I is less than lists.length I plus plus. So this is the first one, this is the second one. So if I was to go in here and say var list equals lists I, now I've got a copy of this object in the list variable as we loop through it. So I need to create an element, right? I want to come in here and say document.create element div. We'll call this new list equals that. Then I want to say new list dot. We could do class list dot add, and we'll just say list card. Right. So all I've done now is create a div that has a class of list card. Then I'm going to like before I even write this to the page. Right now it's doing nothing. I've just, oh no, what did I do? I closed all my windows. That's no good. Hold on, bear with me. I hit Windows key S and it made everything disappear. Where are we at here? Perfect. I'm back. Okay. So this element exists in JavaScript only right now. I haven't written it to any. I'd have to call lists el dot append, right? And then pass in new list. Right, if I do that, then you can see I get two little blank boxes here, right? I have two lists and I have two empty divs. And if I was to inspect this element, you can see I've got, list cards, exactly like I'm trying to do. So the next step, right? I actually need to get I need to start adding some of this information here before I append it to the page. So I might want to come in here and say var title list title equals document dot create element h2, and then I might say list title dot text content equals, and we will say list, and then if you remember we gave it a thing, so we can say list title, right? So now this element exists, but I need to append it to new list dot append list title, right? So I've just now added this brand new element to our new list element that we created. So I got list 1, list 2, pops up exactly like we expect it to. So now I can do the exact same thing for adding all of these items, right? We said we wanted to do this down here. We probably, at this stage when we're starting to build in functionality, one thing that jumps out as being something that will be a little bit difficult for us is we probably need some kind of ID. Well, let's skip that for now. I maybe would start thinking about I would want to maybe attach an ID on this so I know which list I'm in. Then I would need an ID attribute up here, and I'd have to have something like ID. Maybe we would just make it a number, right? Start at 0. Oh, we already get that because we've got the we have our ID here with an I, right? That's already our number. So I can maybe come in here and say new list dot add attribute ID, and we'll just say list underscore plus I, right? So it's gonna be list 0, list 1, list 2, right? We have some ID equals. There we go. Perfect. So now we can see that both of these elements, right, has a list 0 and a list 1. Okay, so I'm just starting to build a real-world implementation of the data model we were doing. Now, I at this stage would probably want to put my inner loop in here, right? So before I even make before I even append this to the screen, instead, I have this comment down here of like, hey, let's add the list items. I probably want to do this all in one swoop. So I might say something like var list element equals document dot create element new unordered list. Okay, and then it's the same type of thing, right? So I need to do list l dot class list dot add list, right? So we get that style in there. All right, and then what we want to do is for, right? So we're going to make a second loop here, and that's the items element. So for var j equals 0, j is less than list dot items dot length, right? Because list is our variable where we're grabbing lists I. So when we're in this loop, I'm going to grab a copy of this, and I'm going to say, hey, now let's loop through each item on this list. Okay, and then I'll simply say j plus plus, and then this is going to do the exact same thing. We're going to say var list item equals document dot create element li, and we'll say list item dot class list dot add item, and then we'll put in the value list item dot text content equals list dot items j, right? So whatever was the we can't just do j because we didn't make it. We made it an array of objects, right? So j is this entire object. J is this entire object. So we'll come in here and say j dot value. Okay, and then the very last thing we need to do in here is we have to say list l dot append list item. Okay, so we're adding all of these list elements to this list element we created, and when we're done with this loop, right? When we're done with the loop, we need to append the entire list into new list. So we'll do new list dot append list l. So now we have a to-do list. Pretty magical. And we've just simply, using JavaScript specifically, gone through and recreated, line by line, all of the elements that we designed in our template. We started with the outermost element, the list card. Right? We said new list is list card. We added that attribute. We added an ID to it. Then we created a title element. Then we said, hey, the text content of that title is whatever was in this list value object. Then we appended it to new list. Right? So this new list variable that only exists in JavaScript right now has an h2. Then we create an unordered list. We create it here. Then we loop through all of the items, creating each one of those independently, and we add those to the list L. We add those to the list L right here. Then we append the entire list element to our new list. And then we say, hey, put this entire thing in our lists L, which was our container. This is our container. So each and every one of these lists is going to be generated on down the list. You'll notice that we are missing in this list L our form, right? We do have a form in here, right? So the last one is add item. It doesn't have the class of item. So we could build this that way, or what I might actually just do is say list L dot inner HTML equals list L dot inner HTML plus, and then I might even just come in here and say li class equals add item, form action equals whatever, method equals post, input, right? I mean, might even just continue adding so that I can keep extra lines going. So I might say input type equals text. What else did I put in here? Name equals item plus input type equals submit, value equals plus sign. Okay, so I'm writing HTML in strings here, so I can just shove it into inner HTML. This maybe saves me a little bit of time. I could have created this element, and then created this element, and then created this element, and appended those children as well. That's where it starts to get kind of clunky. Working with strings like this is maybe not the best way. There's some other tricks I might use to simplify this process, but we'll keep going with this first. And then I would do /form/li, right? So I've created this HTML that was here, and I've added it to the inner HTML of this element that I just created and spun through. I just made this as a loop. And so now if we save our page, now we get our items back. Now we get our HTML elements. Okay? And then just similarly, if you'll notice up here, right, we had a, if we don't remove this, right, I also designed a create new list card. So I probably want to recreate that as well. I probably would do it the same way that I just did this extra element. Right, so instead of lists append right here, let's take this back out. I would probably just write, right, because this is a pretty simple card, I would maybe come in here and say lists el dot inner HTML equals lists el dot inner HTML plus, and then do the same thing. So I'll do div class equals blank list card. Okay, and then I'll do plus h2 create new list h2 plus, and then I need my form action equals something, method equals post plus input type equals text. What did I call the name for this one? Name add list. Name equals add list plus input type equals submit, value equals plus sign plus, and then we just need /form and then /div. Okay, so now, oh, that's inside the loop. Oops. So you'll notice what we did here that caused this to break is that I'm inside this loop. I want to be outside of this loop because I only want it to happen once. Now, we're exactly where we were before, kind of, right? Like, obviously our list items are different, but now it's entirely controlled by the values in this data object. So if I was to come in here and say value equals item 3, completed false, right? Now we get a third item in here. It's entirely JavaScript driven as opposed to being HTML driven. And this is going to tie in super nicely when we start learning about backend servers or data storage. Like, we'll be able to actually store the contents of this entire data model, this entire data object, into either database or into some kind of place where we can store data, so that every time this page loads, it's going to fetch that data and render it on the page like this, so that it will always be up to date. And if we had a remote server where, if we were storing this in a database, you could log into this app from any computer in the world and pull this same interface with your content specific to you. Go ahead, Josh.
So I guess I'm confused. Do you need to write the HTML then? Is that literally just so that way you kind of have an outline of...
We treated this as like a template. And so now that we're at this stage, I can remove all of this code. Gone. And the page still works perfectly. What I had you guys do is design your HTML template so that you knew what you were working with. Because you still have to go in, right? If you were trying to design this page while you were creating your nodes like this, that'd be wild, right? Like, start from HTMLs. That's your document. Start with a structure. And then when you actually get to the point where you want to start implementing functionality, now you can take out the parts that no longer apply, or that you no longer, or that are being created entirely by JavaScript. Right? And I could take out this, right? Since I took out this HTML here, I could take out this line of code that was cleaning this out, and we're going to get the exact same functionality. So I started from the HTML document. I started from a design that I was happy with, and now I'm coding it so that it works.
So when you look at like,
Go ahead. You keep going, and we'll go Creep next.
So when you look at like the website and you're inspecting it, it has HTML in it. Is it? I guess I'm confused. Is it using JavaScript and HTML and just?
Yeah, it's going to depend entirely on what company, right? If you go to Facebook, for example, they don't load any HTML; they load JavaScript.
Okay.
If you view source on Facebook or some of these bigger applications, you're going to see like, 1,000 lines of JavaScript that's going to look kind of wonky. And there are some websites that just will load a single line of JavaScript that loads everything else. Some places are HTML focused. Like, we could have written, if I didn't want to make it so that we could create new lists like this, maybe what I would do is, if I just wanted a single list, maybe I would create my HTML page to have one big beautiful list like you did, and then my JavaScript would just be adding new list items like we were playing with earlier as a part of class. There's no right or wrong answer. What you build and how you choose to build it is entirely up to you, or is entirely up to whoever is paying you to do stuff. They're going to tell you what they expect. And so in this example, when I was designing this for myself, I want to have multiple lists. I want to be able to create new lists and delete old lists. And I could be like, this is my shopping list, and this is my whatever list. So I want to be able to mix and match. So to me, this design met my objectives for building a to-do list system. And now I get to continue to like practice the skills that we've worked on over the last 2 weeks and make this functional. And tomorrow is all focused almost exclusively on events, right? We've been playing with events just because we had to show off this is how we do things in JavaScript. But tomorrow we're actually going to focus on this is how they work. This is how you use them, and this is how you write them. And so from tomorrow, if we're at this stage, right, then I can go in here and say, like, I'm going to add an event listener here that says when this form is submitted, capture it and put it into the list item, right? And then from there, I'm maybe not even going to, maybe what I'm going to do is instead of capturing it and putting it in the list item, like we were doing earlier, maybe all I do is I add it to this and call render, right? So if we go, right, so I'm going to do this from the console so you can kind of see how this works, right? We got our lists, which is our element that has the two lists in there. If I go lists1 dot items, right? That's our array of items. If I put in another element in here, so we'll do dot push, and we'll say what do we call it? Value is new item, and then completed is false, right? And then I can simply call render to-do list again, and now we would have gotten. I should have cleared out the code again. Right. So now we're adding lists on the fly. We're adding items on the fly just using the code we wrote. This is one way to build stuff. All of the important stuff is stored in the variable, is stored in our object, in our arrays that we created, and then we wrote one function that just displays it to the page, right? So instead of having to add a new item each and every time, we simply update the elements, update the page. Any questions? Go ahead, Eric.
What did I miss?
Yeah, I'll start back over from scratch. All right, everybody, this shouldn't take long, just a couple hours. So we started today talking about the JavaScript document object model. We dove briefly into debugging, so let's go. No, I'm just kidding. We recorded everything, so you'll be able to watch it. I'll upload it as soon as class is over. But yeah, we really started getting into building JavaScript, building products for the first time, being able to build things that are interactive and functional and fun. Any other questions? Josh, go ahead.
So in your, I guess maybe I missed it in the JavaScript. Were you also putting in there like kind of like what you would do with Flexbox, spacing everything out and everything?
So that's
or was that
that's all in CSS. That has nothing to do with JavaScript at all.
Okay.
So as soon as I created these classes, right, that was why it was important to design this template to begin with. I said, hey, anything that is in the lists container is going to be displayed flex. Then what goes in the list container is a list card. So that's just a div with this class, and it's going to have a border, and it's going to have a nice little curved radius. It's going to have a different background color. So I designed all of my cards up front because now I can reuse those classes in each and every element that I make. Right. So as long as I add these classes in correctly, then every element shows up exactly like I designed it to. And because we're using Flexbox, it will grow and expand, and if we get to the end of this, it will wrap around to the next line. So I can have an infinite number of lists inside my really cool to-do list system.
So a website really only needs JavaScript and CSS, or it can do a combination of HTML, CSS, and JavaScript. But I mean, it doesn't need HTML.
It has to have HTML.
Is that correct?
Because the HTML tells it to load JavaScript. So this is like a concept called, it's a pretty popular kind of common new type of concept where maybe the entirety of the page will just be a script tag that loads.
Gotcha.
So you have to have at least this much.
Okay.
Right? And then your JavaScript can do everything else, but you're going to have, let's make a new window. Right? It's like the minimum you would need to be a functional product, like min.html, would be like, here, let's make this bigger, right? So I don't need any of this, right? But we do need a body, right? So you'll see websites like Facebook that'll have a script, source equals, load page.js. Right? So load page.js can do everything. It can create all the elements it needs to do, but at a minimum, we have to at least load enough of a structure so the browser knows where we're going. And you can get away with a lot of garbage, right? If we don't have a body in here, right? Like our browser is going to create one because it thinks we're just bad at programming. You could probably even not include a doc type, and you could probably maybe even not include HTML. It would be invalid, but it might work. But it would probably break on some browsers. So if you're trying to build something like Facebook, they're going to put in at least the minimum. Right? If we go take a look at Google, for example, I'm sure they probably do this kind of stuff too. Right? Let's view page source here. Right? Yeah. So they go doc type HTML, and they have a head, Then they have some meta content, right? But then you can see this entire page is JavaScript, right? And they start with this very first script tag that says run all this code, right? It's an entirely JavaScript driven page. And then down at the bottom, it does have some HTML that does some stuff. Like this is the things that is being rendered, right? Like my name, my little thing. But all of the content here is populated by all this JavaScript craziness. Now, this is obfuscated code. Obfuscated means they went out of their way to compress it, so none of these variables look good. Everything's compressed. You would never write code like this. Behind the scenes, they probably have really beautiful, elegant code that they compiled into this format, so that it's run through some kind of automated system. So when they say, hey, this is the version of the code we're checking in, it's compressing it, it's turning it into this type of format so that it saves, like, all this white space, right? All this white space that we have in our code, right? These are all literally bytes that are being sent to the user. And so if you're operating at Google scale, each and every one of these bytes, you can figure like billions and billions of bytes being sent every single day. You strip all those out because now you've used less bandwidth. At our scale, where we're just building stuff for ourselves, none of that matters really, like, especially not in the development stage. If you get to a scale where you're building a product meant to be used by millions of people, then those types of things start to matter. And there is entire frameworks like React or Vue where you don't write HTML, you write JavaScript that generates HTML. You still have to load the page though with like, here's the Vue library, here's my library code. That's a pretty popular modern programming paradigm. And you'll probably, for those of you who go on to careers in software development, you will probably at some point work in a company that uses one of those types of frameworks. Good question. All right, so tomorrow we're going to learn all about events. How do we, now that we've got this kind of page in place, how do we start to capture events? What are all these magical add event listener things I've been doing? What does that mean for us? How can we write code that scales? Tomorrow is event heavy. Without events, right? Events are everything that a user has done or clicked or typed or even mouse movements, right? When we wiggle our mouse around the page, that's an event. And we can capture each and every one of those from JavaScript so that we can make our pages fully interactive. Once we have events in place, everything else is just gravy, like extra features, like animations and flashy things. Like none of that matters if we're able to capture events, work with variables, and get things rendered on the page. Then we can build literally anything we can think of. You even see when I'm showing examples in class, I have to still use events just to even explain some things to you, because we have to be able to show off, like, hey, when you click this button, something will happen. When you hover over this thing, something will happen. Tomorrow we're going to learn how to do that and learn how to explore all the events that JavaScript has to offer. Any questions? No? All right. Well, it's been an excellent class. It's getting funner and funner every day because we are learning to do more and more things. We start combining these things together and just keep practicing and building. Every day we'll get better. All right, well, if there's nothing else, it is 7:50-ish, and we'll see y'all tomorrow.